Okay, in this class we're going to look at graphing the trig functions, but specifically combining transformations. So let's just talk about the general rules and then look at a few specific examples. The order in which we look at these transformations is as follows. We look at any reflections first, then any dilations, then any translations. Okay, dilations are stretches, translations are shifts. So the kind of rule is this, that if B is negative, we get some kind of reflection. If C is negative, we get some kind of reflection. So the coefficients here, B the coefficient of the sine function, C the coefficient of the argument, they lead to reflections and dilations. The things that's been added here, A, this constant added on, that's leading to a translation. Okay, so B and C, well, they lead to reflections and they lead to dilations. So B is going to deal with vertical information. B is going to lead to vertical reflections and vertical dilation or stretch, and C is going to lead to horizontal reflections across the y-axis and dilations as well. And this A here, well, that's going to lead to a translation. In terms of my general kind of quantities we talk about, period, which I'm going to denote from now on with the letter T, amplitude, midline, let's look at amplitude, which I'm going to denote from now on with the letter A, the midline, and the range. What's going to be affected by each of these different coefficients and additions? What's going to happen here? Well, the period, well, that's a horizontal measure of distance, so the period is going to be measured by C, and it's going to be measured in this way. So the bigger C, the smaller the period, the smaller C, the bigger the period. The original parent function, sine of x, has a period of 2 pi. To find the period of my new function, we just divide by the absolute value of whatever C is. The amplitude is always going to be whatever this B is. Remember, B is a vertical stretch, so stretching increases the amplitude or decreasing it depending on whether B is bigger than 1 or less than 1, but the amplitude is always going to be whatever the value of B is. The midline, well, the midline is affected by a translation, a shift upwards. The vertical stretches, the reflections, the horizontal reflections and stretches, they don't affect the midline. What affects the midline is the translation here, the shift upwards or downwards by A. So the midline is always going to be y equals whatever A is here, that value there. And the range, well, the range is going to be affected by both the vertical stretch and that vertical translation, that vertical shift. So the range of my parent function goes from -1 to 1, but by changing the amplitude by B, by causing a vertical stretch here by a scale factor of V, that becomes -b to B. But then also we have to take in this translation, so we have to add on whatever that A is in there. So what I would recommend is that you just remember this, write out your function. This, for any values of A, B, and C, you can find the period, amplitude, midline, and range using this. Use GeoGebra to practice it. Okay, so, and again, think about the order in which we look at these transformations. You look at a specific example here, 3 plus 2 sine 2x. Well, the first thing I'm noticing is there are no reflections, so we don't have to worry about reflections, but there are stretches. There are stretches. There's this horizontal stretch and this vertical stretch. And then there's this vertical translation. Now notice the bigger the value here, the coefficient of x is, the smaller the period is. The bigger this value is, the bigger the amplitude is. So I'm going to go through my period. Here is my first thing. My amplitude is the next thing I'm going to talk about. My midline. and I'm going to talk about the range. So the period is always going to be 2 pi divided by the absolute value of whatever the coefficient in the argument is. Here the coefficient in the argument is 2, so it's going to be 2 pi divided by the absolute value of 2, which is just pi. The amplitude, well, there's a vertical stretch here, a scale factor of 2, so the amplitude goes from 1 to 2. The midline, well, there's a translation here, upwards of 3 units, so the midline goes from y equals 0 to y equals 3. And then the range is affected by two things. The vertical stretch here, scale factor of 2, taking my range of my parent function, which is -1 to 1, that becomes -2 to 2. But then also we have to apply this vertical shift upwards of 3. So we're stretching by a scale factor of 2, shifting up by a factor of 3. So what I'm getting here is a range from 1 to 5. Okay, and we go through those things, on GeoGebra. There's my parent function, sine of x. We're going to look at any stretches. Any reflections? No. Stretches? Yes, the 2 and the 2 here. And then finally the translation. And so the order is important. My function is a plus b sine c of x, so my stretches are 2 and 2. Let's look at the horizontal stretch first, or the horizontal dilation, which is this coefficient of the argument. If I increase that to 2, you'll see this will start to get squished in towards the y-axis. Okay, horizontal dilation, scale factor of 1/2. The period here has gone from 2 pi to pi. Then we have a vertical stretch. By changing this value of b to 2, you're going to make it twice as tall. And then finally my shift upwards, which we said was a shift upwards by 3, so I'm going to move that up to 1, 2, 3. Okay, and you can see all the different stuff in here. Let me zoom in a little bit. Period here of pi, so it's one full cycle here at pi. Going from vertically a range from 1 up to 5, amplitude from 3 up to 5, that's an amplitude of 2. Okay, and the midline there, y equals 3. Let's look at another example. 4 subtract sine of 6. Well, there is a reflection in this case. There's a reflection across the x-axis. That's what that -1, remember that's -1 times sine of x. Then there's a dilation, there's a stretch here. Well, that's going to affect the period, and then there's a shift upwards. Okay, so the period, the amplitude, the midline, and the range. First of all, the reflection doesn't affect any of these quantities. None of these quantities are affected by the reflection. But we'll see what happens in the graph with the reflection in a moment. What is affected is the period. The period of the parent function is 2 pi. The period of this function will be 2 pi divided by the absolute value of that number in there. That's going to be pi over 3. The amplitude, well, the amplitude is still just going to be 1 because the negative here reflects it across the x-axis, but the 1 doesn't change the amplitude. The midline is going to be y equals, well, it's shifted upwards by 4 units, so y equals 4. And then the range of the parent function is -1 to 1. This will be the same because that's a 1, not anything bigger. Okay, whatever the value of the amplitude is, that's what goes in here, negative that to that. But also then we have to add in the vertical translation by a scale factor of 4. So -1 plus 4, that's 3. 1 plus 4 is 5. Range 3 to 5. Okay, and again, let's look at that in action. Let me undo some of those things I did in the last one. Go back to the original. There's my original function here. This is called the parent function for all sine functions. And I'm going to apply these things. First of all, this negative, the reflection across the the reflection across the x-axis. So I'm going to change b to be -1, and you'll see that reflecting. There's the parent function. There's when b is -1. Then I'm going to change the coefficient in here to 6, and we'll see that squish in 6 times as close to the y-axis. So changing that coefficient in there to be 6. Oh, it's only gone up to 5, so I'm just going to change the setting on that to allow me go up to 6. Okay, so there's my function, and again you can see starting here it goes through one full cycle by the time it gets to pi over 3, so the period is pi over 3, and then finally I'm going to shift the whole thing up by 4 units by changing this a here to 4. Okay, so it's 4 minus 6 sine of 6x, 4 minus 1 sine 6 of x. Let's just look where that is. And you can see there the range 3 to 5, an amplitude of 2. The midline is y equals 4. Period is pi over 3. There's pi over 3 right there. All those values we had figured out before using GeoGebra. I've got to be able to visualize. And look at one more example. Note there's a negative here, there's a negative here. The coefficients are both negative, so there's going to be 2 reflections. There's going to be a reflection across the x-axis, because that's a negative, and the y-axis, because that's a negative. Dilations, well, there's going to be a vertical dilation, scale factor of 4, and there's going to be a horizontal dilation, which we'll talk about in a moment. It's actually going to be a stretch out and then a translation downwards by 1 unit. So let's go through our various things: period, amplitude, the midline, and the range. And then we'll see these in action. The reflections aren't going to affect any of these things, but it is, this negative here means it's going to be reflected across the x-axis. This negative here means it's going to be reflected across the y-axis as well. The period is always going to be 2 pi divided by the absolute value of whatever the coefficient is in the argument. Negative x over 2, well, that's negative a half times x, so it's divided by the absolute value of negative a half, and that's going to be 4. The amplitude was a vertical stretch here after the reflection. That negative is telling me the reflection across x. Then stretch it vertically by a scale factor of 4. So my amplitude is going to be 4 times as tall. My midline, well, this is a shift downwards 1 unit. So my midline is going to go to y equals -1. And then my range is going to be affected by the change in amplitude and the change in midline. Parent function range -1 to 1. But we're changing the amplitude to 4, so it's now going to be -4 to 4. But that's before my translation downwards of 1 unit. I have to move everything down 1 unit as well. So my range is going to be -5 to 3. Okay, so let's look at that at work. Let's look at all those things at work. So we'll start with reflections, then dilations, then translations, and see how it all looks. Let me get rid of this last one that we did. Go back to the original parent function. Okay, so not quite there yet. Okay, there's my parent function. Sine curve, y-intercept at 0, increasing while concave down up to a maximum value of 1, decreasing while concave down to pi, changing concavity then, so an inflection point here, decreasing and concave up, increasing and concave up to 2 pi. There's 1 period is 2 pi. So we're going to apply our reflections first. And it doesn't really matter the order in which you do these, but B and C we're going to change to be negative. So maybe I'll start with C, change it to -1, and you can see there's my parent function. There's changing C to -1. Change B, the value of B to -1 for that reflection. So let me look at those. So the first reflection I did was across by changing C to -1, that's across the y-axis, and then changing B to -1 here, changing this coefficient here to -1, that's going to be across the x-axis. So we're back in here, -1 sine -1x. Notice it's actually the same as sine of x. And then we're going to apply our stretches. So putting in a coefficient in here of -0.5 and out here of -4. So changing the value of this one to -1/2. Note what that does. That has stretched that out away. Sorry, let me try that again. That has stretched that out away from the x-axis, or from the y-axis, so the period is now 4 pi units. Changing the value of this to 4 instead of 1, so a -4. That's a vertical stretch, scale factor of 4. And then finally, just shifting the whole thing down 1 unit, goes to there. Range from -5 here up to 3. Midline here, y equals -1. Amplitude, midline's at -1 up to 3. That's an amplitude of 4. Period here of 4 pi. All those things we were able to predict. Okay, so practice, practice, practice. Don't practice till you get it right. Practice till you can't possibly get it wrong.